let me just show you what we're going to be working on today. So last time we finished some basic camera collisions, and today we're going to be updating the camera collisions so that they work better for what we need, and so that you're less likely to see clipping when you collide along a wall. Also, for instance, this is going to be something that we can collide into, obviously, but this one's much thinner, and it's much thinner than the view of the camera, but we're still adjusting so that we can always see the player in front of us. So let me just show you how this is working. So we have our top view here, and if I turn on collision debug, you can see that a bunch of rays are being shot out in the form of a grid along our screen. And what happens is that when our rays collide with the environment, it is adjusting to the shortest ray, and then it is moving the camera based upon that. In addition to that, we can change the size of the grid. So if I come up here, I can go 5 by 3, which might be better for your needs. This is just much smaller, and it's essentially just going to make this probably a whole lot easier for your computer to handle. Really, there's no need to go overkill on this, but you can also, you know, go really crazy and do something like 16 by 9, which is just like, it's way too much, but it still works. Still works quite well. So yeah, and then in addition to that, I'm just going to change this back to 9 by 5. In addition to that, you also have the clip cushion, which is essentially how wide around the camera's view frustum this grid will appear. So if I increase the collision cushion, you can see that it's getting wider and wider. And it's actually based upon the distance of the camera. So as the camera gets closer, you can see that it doesn't actually change the width around the camera frustum, but as you zoom out, it gets wider and wider and wider, and I guess we just collided into something. But for instance, if I move the camera out, you can see it's almost double the size. It is actually double the size because of the clip cushion. So that's what we're going to be doing today. And it actually took me a little bit longer to figure this one out. Since that's the case, this is going to be a much longer video, but either way, let's just get started. So we're just going to start by making a couple changes. First of all, let's make sure that the camera is made a part of the player prefab by going over to overrides and hitting apply all. I also want to make some changes in the camera rig, so collision debug, and that's actually pretty much it. So I'll just apply that one. Next, I'm going to open Pro Builder and create a new shape. This is going to be a cylinder. We'll leave it at 0.5 radius. Number of sides will be 10, and the height will be 10 as well. We'll build that cylinder. And then we have another cylinder we can build here, and I'll just do the exact same thing except make it skinnier. So now we have 2 cylinders, and you can go ahead and place them anywhere. It's not a huge deal. I'm just gonna do that. And then let's take these guys, drop them into test room, and then with test room selected, we'll just change the layer to environments. Even though it's already selected, we want to get this little window so that we can change the children and make sure that cylinder is also considered part of the environment. So that way our camera will collide with it. We'll just go in and open up the camera controller real quick. Now that we're in here, let's just start really quickly by minimizing everything that we're not going to need. So late update, we'll probably need start and update. We won't need camera inputs or camera X adjust. Pretty much the only ones you want to open are camera collisions, update, and start. And we'll start by creating something here for the collisions right underneath layer mask. And we'll serialize this field. It'll be an array of vector 3s. And we're going to call this one cam clip. Probably a good idea if I explain what we're doing. Basically, if we go to our player and look at our camera, you can see that our camera has, it has a view. And this view is represented by like a pyramid shape, but it's kind of cut off at the top. This square here is called the near clipping plane. You can adjust the clipping planes by moving the clipping planes in the camera component. And what happens is if we change this, so let's increase the near clipping plane, you can see that it starts to cut off whatever is clipping it. I don't want to do that. So we want to basically get the 4 points that make up the clipping plane. So let's do that using our array. And so I'm just going to create a new method. We're going to call this one camera clip info. So what we want to do in here is we just want to initialize all of our information that has to do with our camera clipping plane. We're going to take cam clip and we're going to set it equal to new vector3 array, and inside the little square brackets we're going to put a 4, and that should be good for that. So we'll just take camera clip info. I'm going to drop it into update, and I'm also going to drop it into start. Update before the camera collisions because we want to figure out all this information before camera collisions. It's mostly just information we're going to use in camera collisions. Next, what we want to do is we want to actually calculate the Frustum points. So what we're going to do is we're going to go main cam dot calculate Frustum corners. In here we need a rect, and honestly we just need the whole rectangle of the view, so that's going to be new rect 0, 0, 1, 1. And then the second element is a float that represents the Z distance of the camera. Really all we need for that is main cam dot near clip plane. So that's just going to give us the Frustum at the clip plane. Then we need to figure out whether it's a stereo camera or mono camera. It's just a mono camera. And the last one is going to be the vector3 that we're putting all of this information into, and that's just going to be cam clip. Let's actually just have a look at what's happening. If we open up the camera rig, just open up cam clip. So essentially it calculates it all, creates our array, and then once we rotate it you can see that the numbers aren't changing, which means that all of these numbers are relative to the camera. So we're going to have to calculate these positions based on the orientation and the position of the camera. And since this is only happening once and we don't need to repeat this over and over again, I'm just going to comment the camera clip info out in update, and we're going to come back up to these vector3 arrays and create 2 more. So we're going to create world clip and player clip. So for now we're not going to go over what player clip does, but we do need it. So we'll just create those 2 down below here, world clip, and I'm just going to copy this actually, and player clip. So now that we have that, we actually need to calculate it. Let's go ahead and do that inside camera collisions, and we're going to use a for loop. So for int I is equal to 0. Basically I'm creating an I integer that I'm setting inside the for loop. Then we're going to go I is less than cam clip dot length. And so with that I'm just stating that inside the for loop, while I is less than the length of clip, this is going to loop basically. And then I'll go I plus plus, and all that says is that every single time this loops, I is going to increase to 1. So just to break that down, it starts at 0, it loops through and increases by 1 every single time until it is no longer less than length, at which point it breaks the loop. Then inside here we're going to create a new vector3. We're going to call this one clip point, and we'll basically just start with all of the basic stuff that we're used to doing using the main camera. So main cam dot transform, make sure it's transform dot forward. No, let's do up first, times cam clip. And then whenever we want to access an element inside of an array, we just create these brackets and then put a number in there. But I actually want to cycle through every single one, so I'm just going to put I, and it'll automatically cycle through every single time we loop through the for loop. And then that'll be dot y. And then we're going to add that to main cam dot transform dot right times cam clip I dot x plus main cam transform forward times cam clip I dot z. So this is basically just placing all of these points relative to the camera. Let's say for instance I were to take this. I'm just going to take this draw line. I'm just going to drop it in here. So all of a sudden these don't make sense, but we'll just change this to like transform.position, and this one we'll just change to clip point. And we'll change this to magenta so that we can sort of differentiate it from this. This will give us a good indication of what we're seeing here. By the way, this is all relative to the orientation of the camera, but we actually have to put it at the position. So clip point plus equals, we'll just go main cam dot transform position for now. What we see is that our camera, it's basically calculating the 4 points of our camera's frustum, and that's exactly what we want. The only issue here is that if you see, we have that cyan line here that represents our collision ray. If we bring this down, you can see that our collision ray continues to extend, but our camera points don't stay at that position. So what I think we should do is we should put those clip points pretty much where the distance of the camera is. Instead of doing mainCam.transform position, what we should do is we should do transform.position minus tilt.forward times current distance. And actually, if we just go cam distance, it should be a little bit closer to what we need. Alright, and there we go. Now it's going through, it's not actually going through the points. It's actually going, it's inside the camera a little bit. So that is something that's going to need to be adjusted. But we have those, so let's focus on the player clip points. Go vector 3, player is equal to pretty much the exact same thing actually, except I'm going to leave out the z-axis. And then player point is going to be plus equals transform dot position, and that's pretty much it. Then we can take player point and drop it in here, see what that looks like. So that's looking pretty good. Cool. As you can see here, our rays pretty much extend. They don't extend anywhere actually. They intersect directly with the camera's view frustum. And so my only concern for that is that we kind of need a little bit of extra space around the camera, and we basically need to make sure that if the camera is intersecting with anything, that there's enough space around the camera to make sure that it doesn't clip through like a wall or something. And so in order to get that right, what we're going to have to do is we're going to have to create like another cushion. And so this is going to be like a public float clip cushion. And we'll set that equal to 1.5. And I'm going to place this one at the max distance, I think. So instead of cam distance, we'll just go camera max distance. And then I'm going to take this, because I need the Z position to be pretty much exactly where it is. And we'll just go clip point plus equals main cam on the forward axis, and then before that we'll go clip point times equals clip cushion. So this way it extends outwards, but that doesn't affect the forward direction of the clip. So now we have just the max ray, basically, showing us how far it can go and all of that, and it has a little bit of padding outside of the camera, which is exactly what we want. Alright, so from here I'm actually starting to think that clip point and world clip is probably a bit of a misleading name, so let's quickly change that to clip direction. And the reason why is because it's extending to the max distance. So we're just going to need to get a direction for our rays. So down here, let's just go clip direction I is equal to clip point minus player point. And we'll grab this, drop it into brackets, and then outside the brackets dot normalized. And then player clip I is going to be equal to player point. So from here we'll just take, and I think this is pretty much just going to be temporary. take player clip and clip direction. I guess that's going to be player clip plus clip direction times cam distance, probably. Alright, I'm pretty satisfied with that. So that's basically the backbone of what we have. From those points, one of the things that we can do is we can calculate the rest of the points that we need. And it's kind of going to require more arrays, basically. So we're going to need to create a couple more arrays. Let's do that real quick. So this is going to be ray call origin, ray call point, and then the last one is going to be a Boolean array, and this one's going to be ray call hit. So the idea is we're storing all the origins of the rays, all of the points where they collide, and whether or not they're actually colliding. And to do this all, we're going to use, since we're going to use a grid system, we actually need to create a couple of integers. So let's go here and go public integer, and we'll call this one ray grid x and ray grid y. And I'm actually just going to straight up set these, so that's going to be 9 and y is going to be 5. I'm just basing this off of like camera resolutions. And then what we need to do is we need to initialize our 3 arrays based on these 2 numbers. And we are going to basically multiply them inside of our camera clip info. So we'll just create a new integer, call it rays, and we'll set it equal to ray grid x times ray grid y. And then here we'll go ray call origin is equal to new vector 3 array of rays. Then I'm just going to copy this. We'll go ray call point is equal to that, and ray call hit is not actually going to be equal to that. We're going to have to change vector 3 to bool. Next, I actually want to set this up again, because let's say you want to change the grid mid-game. I mean, the player is not going to be able to do that, but like as a developer, you might want to do that. So let's reinitialize that, and we'll just grab this and go if these 2 numbers are not equal to ray call origin dot length, then we're going to do that one. We'll just separate those from that. I'm just going to remove this serialized field here, and we're going to continue on down here, and this is actually going to require a lot of stuff. So here what we're going to need is we're going to need a couple of things, because since we're using the x and y coordinate to cycle through things, we need to create an integer, and we're going to call this one current ray, and we're going to set that equal to 0. Next, we're going to create a Boolean, and this one's just going to tell us whether or not we're colliding. So is colliding, and we're going to set that equal to false. Then we're going to create a float here. We're going to call this one ray x, and we're going to set this one equal to ray grid x minus 1. I'll explain more why we're subtracting it by 1 later, but I do want to convert this into a float for what we're going to be doing later. And we'll just copy this, and we'll just go ray y is equal to ray grid y minus 1. In order to cycle through all of the elements in this, we're actually going to have to create 2 for loops that sort of form a grid. So we'll just go for integer x is equal to 0, x is less than ray grid x, x plus plus. And then I'm just going to copy that one, paste it in here, and we'll go change all of these to y, and then change this one to ray grid y. So now every single time it loops through x, it's going to loop through every single y, and that's going to form like a kind of like a grid. Alright, now I'm going to grab these 2 and put these in here inside the y for loop. We'll just leave this as is for now. From here we actually need to start defining our points, and as I mentioned, we calculate all of this. We're going to be using all of these to sort of interpolate where each line is, essentially. So let's do that by creating a couple vector 3s. So this one is going to be, it's going to be clip upper point. We'll just put a little underscore here. And it's going to be equal to vector 3 dot lerp. let's walk through something real quick just before we actually start. All right, so if you imagine that this square is our screen, and on this square we have our 4 corners, right? So these 4 corners are the ones that we put into the array, and the way they were put into the array is like this. So this is element 0, this is element 1, this is element 2, and this is element 3. In order to figure out the grid of our array, we're going to have to break this into a couple different steps. The first step is getting the top point along the upper portion of the screen. So if you'll just imagine, right, so this is these are the 2 top corners, right? And along here, this is what we're going to be grabbing. We've got 9 points. And similarly, down below, we've got the same number of points. Now let's say hypothetically that we end up getting a point like right in the center. So this one and this one. What we can do is we can grab the interpolated points between these 2 elements and these 2 elements, and then interpolate again a point right here, somewhere along this grid, including, by the way, the little X's. So the grid could start at the corner or something like that. But either way, we'll be doing this for every single point along the array, generating an entire grid of rays, and this will allow for the most coverage on the screen towards the player to help avoid any issues that might come with having thin objects pass in front of the camera. And you can do as many or as few rays as you want. I think there's probably going to be like an upper limit, but obviously if you decide to go lower, it's probably not going to be as bad. Alright, so let's get that done. So the first point is going to be clip direction 1, then the second one is going to be clip direction 2. And the float between these ones is going to be x over ray x. The reason why that is, here's why we subtracted it by 1. X is equal to 0, which means it's going to be right on the left side. So it's just going to be clip direction. And as we increase by 1, x is going to be closer and closer to ray grid x. But it's never quite going to reach ray grid x, which means if we leave it as that, this will never actually be a point. But we want this to be a point, so we have to subtract it by 1. So all of the other points in between are going to be interpolated based upon whatever x is. Alright, so let's copy this, and we'll just create CL for cam lower, or clip lower, and we'll change this to 0, and we'll change this one to 3. Next I'm going to copy these 2, and I'm going to change this to player upper and player lower, and we'll just change this to player clip and just copy that around. So we've created these 2, and this is just basically creating the 2 that represent the sort of upper and lower lines of the array. But now we actually need to create the sort of in between on the y-axis. And we're actually just going to put these directly into the origin and the direction. So let's take the cam ray origin and let's go vector3 dot lerp, and we're going to go from pu point pl point, and then we'll go y over ray y. Then we can pretty much just copy this into our cam ray direction, and instead of pu point we'll just change this to cu point and cl point. Alright, so now we basically have a origin and a direction based on the grid. So I'm actually going to take this one and delete it because we don't need it anymore. And I'm just going to copy this and paste it right into here. So this should give us what we're looking for, and it'll just sort of show us ideally the grid that we have set. So let's take a look, and there it is. There's our grid. So that's going to sort of handle all of the collisions of the camera. Alright, so let's start setting some things up. So let's add the cam ray origin to our ray collision origin array, and we'll use current ray as the index. Set that up as camray.origin. The issue here right now is that current ray is set to 0, and there's nothing changing that. So we're going to have to come right down to the very end of our y for loop and go current ray plus plus. So that way every single time it loops through y, it increases by 1. So we're always looking at the next element in our array. After that, let's just copy this and drop it in some brackets. We'll else and drop this in there, drop this one in here. We're going to be making some changes to this one, but let's start out by saying if it has collided, then is colliding is equal to true. Next we need to say that ray call hit current ray is equal to true. Then after that we need to say that ray call point is equal to cam ray hit dot point. Oh, and again I'm forgetting the current ray. So now that we have that, let's actually set up our collision debug real quick. And I'm actually just going to copy this directly because I want this to be camera hit point and this one is going to be camera hit point. So it's going from camera origin to the point where it hits, and then from the point where it hits to the camera distance, and then I'm going to change this color to magenta. So that way we can see where it's hitting and where it's not hitting. And I'm just going to very quickly show you what that looks like right now. So this is going to be really handy for telling us like what's going on. You can basically see all of the parts that are actually colliding with the camera. Alright, now let's actually make those collisions count. And I'm just going to comment this out for now. And we'll start by checking to see if the camera is colliding. So if is colliding, then we're going to do stuff. Else, we're, I guess, not going to do stuff. So inside here, we actually need to do a couple of other things. Let's continue using current ray. So let's set current ray equal to 0. And we also need to create a new float. And we're going to call this one min ray distance. And we'll set that equal to float.max value. So what we're going to do is we're going to cycle through all of the distances between ray collision origin and ray collision point if they have hit. And we're going to essentially find the shortest distance and use that to determine where our camera needs to be. So we're just going to create a really simple for loop. We'll go integer I is equal to 0, I is less than ray call hit dot length I plus plus. Next we need to check to see if ray call hit I is true. So we want to get the float collision distance between vector3 distance, ray call origin I, and ray call point I. And then what we're going to do is we're going to check this distance against our minimum ray distance, which in the first element is always going to be shorter than minimum ray distance, which is why we set it to the max value. So if call distance is less than min ray distance, then we are going to do stuff. First of all, min ray distance is equal to call distance. Current ray is going to be equal to I. So we're just setting the index to whatever is shortest distance. And by the time we get to the end of the loop, we will have determined what the shortest distance is so that we can use that to drive our camera. Alright, now after that, we need to find the center point of the camera. And I mean, I imagine we can just use the camera's position if we wanted to, but since the camera moves around, we're going to have to use something else. So we'll just go vector3 and we'll just call this one clip center. We'll make that transform.position minus tilt.forward times current distance. The next bit is something that I didn't come up with myself. I actually had to go and talk to my dad, who's a mathematician, to help me figure this out. I actually still don't understand it really, but this works. And basically this is just something that we can use to help us find the center point relative to our collision point, if that makes any sense. So we're going to go adjusted distance is equal to vector3 dot dot, and our first one is going to be negative main cam dot transform dot forward. I'm not sure why it's negative, but for some reason we have to get the backwards direction of the camera. If we get the forwards direction of the camera, it doesn't actually work, which is a little weird. And then we're going to put a comma here, and we're going to go from clip center minus ray call point current ray. After that, we're going to go adjusted distance is equal to current distance minus inside brackets will go adjusted distance plus collision cushion. And then just for good measure, adjusted distance is equal to mathf.clamp will go adjusted distance, and the minimum float will be 0 and the float max will be camera max distance. And then I guess down here we'll just go adjusted distance is equal to current distance. And that should be us. I believe that's everything we need. So let's just have a look to see if it's even working. And then let's put it through like a couple different stress tests to see how well it actually works. Alright, so we can see that it's avoiding the ground, which is good. I'm just going to get us a little bit of an overview over here. Maybe give me more space here. So let's check this against the wall. So we clip right here and camera's in front. Gonna hug the wall. There's very minimal clipping on the right side. I'm thinking that one of the things that could be done to reduce this is increasing the cushion around the camera. Alright, let's bring this down here. I feel like it's working pretty damn well for what it is. This is probably the part that's going to be my favorite. Let's go from top view. And we can see here that, you know, our camera is adjusting based upon the position, based upon the form of that pole there. And then since this one's much thinner than the actual camera, we're basically making sure that regardless, like you can see, if we were only to use the outside clip points, we wouldn't have adjusted for this. We wouldn't have been able to. If we had a middle one, maybe. But if we wanted to go even thinner than this wall here, that would have been nearly impossible. And I think based upon the distance, the gap distance between these rays, we can make some pretty thin objects without worrying about too much. And I don't think we're going to have any real problems, because I don't see us going any thinner than that. Well, that's our camera controller finished. And if you learned something from this video and you enjoyed it, please consider leaving a like and subscribing. It really helps me out in the long run. I've got a couple of announcements to make. The first one is pretty exciting. On July the 31st, I'm going to be doing a live stream at about 5 o'clock Pacific Standard Time, and this is going to be a 3D modeling live stream where I'm basically going to apply all of the techniques that I've experimented with over this last little while and just making a model for the game. Eventually I'm going to turn that process into a sort of tutorial that I'm going to be uploading to the channel so that you can also use those techniques to learn how to 3D model. And I think that it's going to give us the closest aesthetic to the World of Warcraft art style, while also using new techniques that World of Warcraft didn't have when it came out and still doesn't use to this day because of that limitation. So yeah, that's going to be fun. And I guess the second announcement is a little bit more of a confession that is kind of half of an announcement. But I got lazy with the audio in this video, and you may notice it, or maybe not, but the reason why is just because, first of all, this video is way too long, and second of all, I'm going to be using different equipment for my videos going forward, so that's pretty exciting. You will see a noticeable difference in the quality of the videos, and hopefully that's a good change. So yeah, next up is swimming, and I'm fairly excited to be doing that. And even though it has taken us this long to get here, I'm still very happy with the amount of progress that I've made, and also very happy with the experience as a whole. And the final announcement is something that I've been leaving in the description for a little while. Basically, I have a Discord. It's pretty small. It only has 7 users, including myself, and I'm pretty sure 2 of those users are the same person. So yeah, if you want to come in and have a chat, please feel free to join the server. And again, thanks for watching. Bye.
Super trooper, super trooper, super trooper, and he sells soup.